G'day again, Steve from offthegridnoz.com. I was actually going to say I was somebody else, and I get so sick of hearing that intro. Kerry plays our videos back here and hear my own voice with that intro, and I thought I'd call this one something else, but no. It is unfortunately still Steve from offthegridnoz.com. This is the building part 2, structurally insulated panels, the system that we used on our main house this time around. I'm sitting inside the house now at the computer just waiting for a video to upload. Should be outside doing something else, but I missed out a couple of minor facts in that first structural insulated panels video, and that was the structural side of it. Now, people might ask what holds this stuff up underneath, and I showed that. Well, as far as holding the rest of the building up, I'm focused on a wall there. That's an internal wall. You can see that there. It goes from the floor straight up to the roof. Now there's no timber work in there, there's no beams, there's no steel. These structurally insulated panels are actually load bearing to a point. I won't make that a general statement, but they're load bearing to a point. You'll notice when you look at transportables, quite often they're built out of this material. There's no internal structure, there's no external structure. The actual panels, because they're two layers of colorbond sheet metal, in this case with 100 mil of insulation material wedged in between, they call it sandwich panel. They're actually very non-compressive, meaning they will take vertical loads very well. You can see up there the roof on this place is made out of the same material. It just sits on top of the wall that's got a piece of C-channel on, like I threw in the last video, showed you in the last video. The C-channel up there. That C-channel sits on top of the wall, then the roof literally just sits on top, screwed down with some big metal thread screws. But these walls don't need any other additions. Once you put the channel on the base, like that, and the channel up the wall, like that, and the channel up the top, across, the whole panel itself becomes very structurally sound. Getting a bit blurry out there, there's a window, change the camera around. Yeah, they get very structurally sound, they become very strong for vertical compression. So if your roof, as long as you haven't got a second story on there, that would take some special attention. But if you're only putting an EPS roof or a structurally insulated panel roof on top of these panels, no extra structural materials are required. I'll show you above the doorway where the air conditioning is there. There's what looks like a beam, quite a span there, there's about 2.5 meters. As long as you make the panel, you can see up there, that panel on top of the doorway is about 2 foot thick or 600 mil thick or deep, whatever you want to call it. Once you rivet the channels around the whole exterior of that crossing, that piece of EPS becomes like a load-bearing beam. And I can tell you right now, you could park a car on it. This stuff, once it's riveted together, is unbelievable as far as strength goes. It gains its strength from each other. An individual panel laying on the ground, fairly lightweight, won't bend laterally very easily, but they don't take on their full strength until they're all riveted together in components, and that way you can get across the tops of doorways. You can see over there, I'll get up off my chair, see it on top of even smaller doorways. No extra lintels required, a piece of panel riveted together, EPS on top, structurally insulated panels on top. The panel above the door becomes the structural support. So that's another beauty of this stuff. From the floor to the ceiling, you have a structural load bearing feature built into this material, no extra effort. This is actually our library, would you believe? That whole wall there. Right, we start from the office. When you look down here, that whole wall, we're going to put a library on it. We had a big library in the other place, and that wall's about nearly 4 meters long. Bit hard to pick up in the camera, in the shot, but yeah, 4 meters long. We're going to put a full library right through there. They look great. So this is like a sitting library area, just in case anyone was interested. Not that you probably are. But yeah, so these SIPs, they are very structural. As far as the ceilings go structurally, well, you can see in the lounge room, these sheets on this side of the pitch are about 4.5 metre span. No support underneath. This stuff, I can bounce around up there, and I tell you, this stuff is stiff as buggery. You can look up load, suggested load bearing capacities to do with your build or needs for your build. There are charts available, but a bit of common sense. If you're building off grid, and especially if you're building something that's transportable or maybe portable later, the spans are pretty straightforward. Like I said, this is a 4.5 metre span, not a flinch in it. The span in there is only a couple of 2.5 metres, and then we've got another span across the bedrooms and the walk-in robe. Walk-in robe I still haven't finished either. That little, another room hiding in there. Nice big walk-in robe, but I haven't shelved it out yet. So yeah, the spans, we've got a 3 metre span, we've got a 2 metre span here, 2.5 metres, and we've got a 4.5 metre span in there. No extra support required. Even across the windows, which I'm still yet to seal up, the insulation material above, the EPS panel above, once connected together with the channels that support, tidy up the edges, maintain the support. The roofing sheets, there's not enough load on them to bother it. You can get up there and bounce on that like a banshee, not a millimetre of movement, alright? So it's a bit of common sense. You just got to use your imagination when you put your plans down or you draw your picture up. Make sure that you do allow for, you know, a decent size amount of material above any openings. Once you rivet that all up, that material above the openings will take most of the load generally. Now obviously that doesn't hold 100%. If you've got a 4 metre span, you might need to do something different across a window or something. But if you're dealing with full panels like these ones up here, a full panel, once they're interlocked together with the rest of the panels, becomes very rigid very quickly. Alright, so I did miss that out in the last video. It was all I really wanted to mention was the structural side of this stuff. Very vertically, not a problem. They just sit on the bottom, they sit across the tops of the joists. In this case we've got the EPS underneath, like I said, so it adds a little bit of more lateral support underneath the walls. But pretty much you cannot say between the edge of that door and 2 metres away, you cannot compress these panels vertically. You can't put any load vertically on them that will cause that panel to distort. It will span the 400mm of your joists and not flinch. I mean literally not flinch. You could drive a truck over the top of it. This stuff is very stiff, very strong. So this is just to do with the structural stuff. Hope that adds a little bit more information. I know you looked at that other video and I tried to do it a bit quicker, you know, to glossary over things. The tools required, I didn't really go into that much. Basically, you need a pop riveter, a damn good pop riveter. You need a saber saw, as I mentioned, to cut the panels, to slice them, a bit like slicing bread. You need a jigsaw, some of the 100mm panels, to get the cuts nice and, I like nice and neat. So when I make a cut, say up the side of that wall, I'll mark both sides of the wall and spin the panel over on the ground and slice it with a jigsaw. You get a nice straight cut that way, you get an even cut. The 100mm thick stuff tends to make the saber saw blade wander a bit, which isn't a big deal because you've got cover channel on all edges anyway. But yeah, so you need a pop riveter, you need a saber saw, you need a jigsaw, you need a couple of good pairs of snips, need a good pair of pliers. Occasionally you've got to bend because of sheet metal, you might knock it and you need to straighten up an edge or something. You need a good pair of pliers. You can get little hand folders, which are like a wide blade pair of pliers. They're good for tidying up edges also that maybe don't want to go together easily for you. So yes, there's only a handful of tools required. A bunch of good drill bits obviously, but that's it. So yes, structurally, not only clean, neat and very cost effective, but structurally very, very versatile. Alright, so that's all I wanted to add to it. So this is probably the quickest video I've ever made. And I really should go outside. I have plenty of work to do. So this is Steve from offthegridnos.com. Just an amendment to structurally insulated panels. Hope this has been of some help to you. All you new people out there, you might watch all these and go and build your mud brick like I mentioned in the last video. And that's the whole key. If you want to build a mud brick, this stuff's probably not going to interest you, but if you're a little bit more modern, looking for a clean, functional, cost-effective, very low cost to build, low skill level required to build, not many tools really required to build it, and if you don't like painting, this stuff's great. We've left everything exactly how we bought it, except the outside. We did slap some acrylic on that just to make it blend in with the bush. Anyway, Steve from offthegridnos.com, to subscribe, like, all of that stuff. That's the end of my videos today. I try not to do any more than about one small video a day. And we'll catch you on the next one. Cheers from me and Kerry. Bye.